Hey everyone, welcome to the most opinionated space podcast on the internet.
Ad Astra, the podcast where we talk about the intersection between space, policy, and technology.
I'm Jack.
And I'm Newton.
I have a Master's of Public Policy degree with a concentration in Science and Space Policy.
And I'm a PhD in Computer Science and an all-around tech geek.
All right, so as we mentioned last week in our somewhat disjointed episode, the t-shirt competition is over. Our winner, Antonio Perinace, will be coming on the show in the next couple weeks to give us an idea for what the inspiration behind the design was, why he's interested in space, and what you can look forward to seeing from him. And also a link to to purchase a t-shirt should be available soon. Hopefully in time for Black Friday. If not, sometime before the holiday season. They make great gifts. Yeah. As our podcast is a gift to you every week.
Yeah, absolutely. Yeah. Sorry about last week's episode, guys. We had a few scheduling conflicts there. We also were at multiple events that were happening throughout that week. So things got a little busy leading up to the week of Thanksgiving. So, yeah. But we're back. We're back for a tight 45-minute to an hour episode. We'll see how this goes.
Yeah, you guys will hold that to us as people look at their screens and it shows an hour and 30 minutes left.
But we have time for a brief recap of the week, as a certain British host says.
So what are we talking about this week?
So we're getting into, and latest from Washington, we're going to talk about Virgin Orbit getting their first customer, as well as SpaceX wanting the government to help pay for BFR. We'll dive a bit into some FAA policy in commercial space as well. In Space News Highlight of the Week, we're going to talk about the biggest event this week, which was JPSS-1 being launched at long last. In international news, we're going to talk a little bit about some of Japan and India's plans to go to the moon. And in latest in tech, we're going to talk about an upcoming solar probe that will be launched in 2018. And then in Coming Soon to Space, we'll, as usual, talk about Coming Soon to Space. All right.
Well, actually, the Coming Soon to Space is a list of recommendations for
it's a surprise.
Christmas and other holiday gifts.
Yes. Yeah.
But yeah, so let's start off this week with what's happening in Washington. So Richard Branson, his company Virgin Orbit is in the news. So Virgin Orbit just this last summer split off into its own company after Virgin Galactic has been developing their White Knight 2. The White Knight is the plane itself, and then Spaceship 2 is the actual rocket that's supposed to be carrying humans carrying tourists into space, and it's an air launch to orbit type vehicle. And so that means that an airplane carries the White Knight 2 carries this spacecraft up to a certain altitude and then lets it go, and it ignites its second stage engine and gets it to orbit. So that same concept is being applied to what Virgin Orbit is doing with something called the Launcher 1, which is going to fly underneath large aircraft. And I think it's also going to be the Sea Knight 2, if I'm not mistaken. But this whole contraption is going to be specifically designed for small sets, so things that are about 200 to 300 kilograms.
Right, they're launching it all from underneath the wing of a 747 is what they're trying to do with this.
Is it a 747? It's not because I'm looking at the picture of this thing and it's pretty big, but also White Knight 2 is supposed to be really big as well. But yeah, I think you're right. It might be a 747. Anyway.
Yeah, that's fine.
So the big news this week is, and this is coming out of Luxembourg, where the New Space Europe conference is being held, that Virgin Orbit got its first contract through the Department of Defense. And so DoD has this program called the Defense Innovation Unit Experimental, DIUX, which is a test program that finds, they don't explicitly go out to find new and smaller companies to carry out these missions, but that certainly helps the case for it being an experimental program focusing on experimental technologies and things that could be, big technologies in the future. And so Virgin Orbit was selected to launch a selection of Space Test Program payloads, all to be chosen at a later date, closer to the launch. And Dan Hart, the chief executive of Virgin Orbit, says, we spent the better part of 6 months or so in discussions. DIUX has the mission to be agile and really drive forward, so we'll be able to really approach things quickly and efficiently. So the whole idea behind DIUX is, to develop these experimental technologies, and Virgin Orbit being a fairly new company, and Virgin, just everything space under the Virgin brand is very new, even though they were I would probably say Virgin Galactic was the first new space company, because it was Scaled Composites that built Spaceship One and White Knight One. That won the X Prize back in 2004, making them the first, the first fully commercial spacecraft to fly in orbit twice within 2 weeks. So Virgin Orbit is very early on in their development process. Even though they have a very long history in the new space arena, they've had a lot of delays. I mean, Virgin Galactic, ever since an accident back in, I think it was 2008 or 2009, an accident with Spaceship Two, they have not flown really since then. They've flown a couple test missions, but haven't flown to orbit yet. So this whole, Virgin Orbit getting this contract is really going to be a boost, not only for Virgin Orbit's credibility, but just for the whole Virgin brand, giving them sort of an influx in cash in research and development.
And they're looking towards 2019, right? For that?
Yeah, I think that's the general idea. I mean, like the article on Space News says, the Space Test Program payloads are going to be determined at a later date. So if Virgin Orbit doesn't think that the Launcher 1 is going to be ready by 2019, then they might push it off. Or if those payloads themselves aren't, the ones that are designated for this mission aren't developed yet, that could also push it off. So there are a lot of moving pieces here that are going to have to be organized by both the commercial sector, Virgin Orbit, Virgin Galactic, Richard Branson and his team, as well as the public sector, Department of Defense, Air Force, and also the Space Test Program, are going to have to all kind of coordinate and make all their schedules fit together and make sure there's no cost overruns or schedule overruns that severely delay the mission. But this is really exciting to see that Virgin Orbit's sort of back on the horse, so to say, for commercial space.
Yeah, and doing something that's very applicable to DoD. I can see them having a number of these contracts in the future. So getting this first one out and sort of refined underneath the DoD makes a lot of sense. So
yeah. I mean, they got the money to do it and the programs in place to help develop this experimental technology. So speaking of government funding of commercial space flight, so SpaceX in their she's the president. President of SpaceX, Gwynne Shotwell, at the same conference, the New Space Europe conference, just this last week, mentioned in a conversation that the Big Falcon rocket, BFR, that Elon unveiled at the last IAC in Adelaide, is going to be hopefully funded in part by government contracts. That the government is going to come in and purchase rides on the BFR or using the Big Falcon spaceship, which is the crew capsule that will be sitting on top of it.
That's not surprising at all.
Yeah, well, I mean, SpaceX has a long history of depending on government support to help develop key technologies. I mean, when it comes to the reusability aspect of SpaceX, they really didn't use much government funding for that, and they got a lot of credit for that because that was completely independent of the missions that they were given from DoD, from NASA, from NOAA, and they developed this capability.
But partially subsidized by those missions as well as other commercial customers that they were carrying on regular rockets.
Yeah, they diffused the cost across a number of partners that worked with them to send payloads to orbit. But now, it's 10 years later, 15 years later, after SpaceX was first started, and they're doing exactly what they want to be or wanted to have been doing a couple of years ago. but they're at least doing it. They're launching rockets and landing them and reusing them.
Yep.
And the Air Force, well, this is something we covered a couple weeks ago, the Air Force is actually taking note and saying, hey, maybe this isn't such a bad idea to launch on a reflown rocket. It's going to save the taxpayers money. It's going to be reliable, assuming Elon is not boasting too much. And, it could be the future of space. And so the government wants to get on top of that as soon as possible so that they can help further that development. When it comes to BFR, there's not really a government case for a super heavy lift vehicle, unless you're sending humans to orbit or massive missions to the outer planets, the inner planets, Alpha Centauri. There's not really that much need for something as big as the BFR. And really at this point, it's back of the napkin math. And I guess Newton, you can talk a little bit more to this of just like how much is BFR Elon boasting, or is it him saying, hey, we actually have some of this technology in development. We just need to begin getting customers to help fund this development.
Well, I think he is looking at getting getting a portion of it subsidized to sort of give it a goal line, right? To figure out, because you can just say almost any company, well, that's large enough could just say, I'm going to come out with a massive rocket, right? From a practical standpoint, there's a lot of engineering that goes into it, but it's not sort of a miracle of of science to do so, right? More fuel gets you more delta V, right? So really what this is him trying to have the government work with him to sort of set up customers for the future of this. Ideally, he would like NASA, but it sounds like Air Force would be a great option as well. I know they just recently had an entire conference about procurement of new capabilities for space. I think that might be one of the ones that Elon is going for, and it's particularly now that the Space Corps talk seems to be dwindling, and a number of the capabilities that they were talking about at that conference were related to that originally, but now, in terms of future launch services and the government getting a couple of different types of launch vehicles, this could be a major one. And if that's the case, then he could, create that underlying technology for the BFR, extend his capabilities, the current capabilities that he has, and then create a commercial rocket off of that. So we'll see what happens.
Well, and Shotwell also noted precedent too, and a number of other folks have also noted this, that the Air Force has already contributed $33.6 million to the development of the Raptor engine to replace the RD-180, and the Raptor engine is what's going to be on the BFR. And also last month, there was an announcement from the Air Force that they're going to put $40.7 million more into that development. So there is precedent within the government space to fund commercial space endeavors that are kind of out there, because I guess it's not necessarily spin-off technology as we think of spin-off technology, but it's developing components that then can be used in other missions. So the Raptor engine, although it's integral to the BFR program, it could also replace a number of other mission architectures that require an RD-180 now, but they could replace it with a Raptor engine or a BE-4 if you're looking at Blue Origin as well. And it's not just the Air Force that has done this. We've talked a number of times about the COTS program, the Commercial Orbital Transportation Services program from NASA, that put $406 million into SpaceX to develop the capability to send a Dragon capsule to the International Space Station full of supplies. And that has, according to Shotwell, that $406 million has had to be some of the best investment money that NASA and the U.S. government has ever spent.
Yeah.
I would say that it's certainly reasonable that SpaceX should expect future government funding for components of BFR, but for BFR as a whole, I don't think there's much of a government case for a super heavy lift vehicle like that.
Well, no,
this is something that would be almost as I think it's actually supposed to be bigger than the Saturn V.
Yeah,
And the
well,
only thing that's going to rival it is going to be the SLS, which is going to be about the same size as Saturn V, if I remember it correctly. Yeah, so this will be an interesting thing that we'll keep our eye on. If suddenly there's a $3 billion contract for SpaceX to build the BFR, we will try to be the first to report that.
Mm-hmm.
And I guess to round out our conversation about what's happening in Washington, representatives from 4 commercial space companies, Lockheed Martin, Sierra Nevada Corporation, Orbital ATK, soon to be Northrop Grumman Orbital ATK, and Astrobotics have come out in support of FAA AST, so the Office of Commercial Space Transportation. It was a panel discussion put on by the Space Transportation Association, where they were asked the question, do you support FAA as being the go-to place for commercial space for non-traditional space activities? And all 4 of the representatives from those 4 companies said they do support FAA AST, and it kind of went back into this whole question about what parts of the federal government do what when it comes to commercial space.
Right.
Are we going to consolidate everything and put it into NASA, or put it into a different agency, put it all under FAA and increase the budget, hopefully? Or is it going to be diffuse as it is currently, where you have, Department of Commerce has some aspect of it that they work
Well, you have
with
a
or
number
work
of different
on.
organizations running it. I mean, I look at things like in-orbit launch services, or in-orbit maintenance services, and you have the FAA running launch, the Federal Communications Commission overseeing things like satellite communications, national, like you have NOAA regulating Earth imaging. So you have all of these different agencies regulating different parts of common missions. So this is
and then throw in the Air Force and whatever configuration they end up having for space, whether it's a Space Corps or they focus specifically on like JSPOC or JIXPOC, where they control all of the surveillance, making sure that the on orbit servicing isn't going to run into another satellite, or making sure that this launch is corresponding with making sure that the orbital debris is clear for a space launch.
And determining those rules does take every agency, but there needs to be someone sort of sitting at the front of things, kind of being that final authority, as opposed to people just kind of throwing the football back and forth with each other.
Well, that's the hope of the National Space Council, right? That it would be a place of consolidation, that it's, a room that they meet in every 45 days or however often the NSPOC is going to meet, that they can have these overarching policy discussions of who's doing what, why, and where, so that no one's stepping on anyone's toes, so that something that FAA doesn't interfere with the jurisdiction the FCC has, or the jurisdiction that NASA has, or NOAA has, or Air Force, and making sure that that the broad strokes are taken care of, so that when we're in the thick of it, when we're day-to-day operations, you don't have to worry about how it fits into the overall scheme of commercial space flight. So that's still the hope that NSPOC is going to do that. But as it stands, FAA AST is the go-to place when it comes to commercial space launches. If you're a commercial company that wants to launch something into space, whether that's low Earth orbit, geostationary orbit, sun synchronous, cislunar space, trans-Martian space, whatever it is, you go to FAA AST. If you don't, and even if you have a contract from NASA or NOAA or Department of Defense, you still got to go through this $20 million a year office and make sure that you're not going to run into any, wayward planes or anything.
Right. So, all right. Well, so we're making progress on that. I mean, this is just going to be a continued discussion over the next decade. We're kind of in the decade of policy before we get to sort of a decade of sort of that renaissance that we talked about of human exploration. We need to kind of nail down what we can do around Earth policy wise from a commercial perspective, and then we're going to get to that. I kind of see that being the next sort of in the next 20-year timeline of space. But anyway,
hopefully 2018, 2019. Was it 2018 that we said was going to be the year of commercial space? I think it
Yes,
was.
it was
I
2018.
I
Yeah.
think when 2018 gets here and we're seeing, the major tests for SpaceX, Virgin Orbit, Blue Origin really kind of come to a head,
Hmm.
that we're then going to start seeing the fruits of our labors when it comes to policy. People there's, oh, why are we focusing so much on policy? Why aren't we doing anything? Well, if you do a lot of things and don't have any regard for the consequences, you can run into the situation we're in now, where there's tens of thousands of pieces of debris in orbit, and even more that we can't even track, and it's an unsustainable space ecosystem.
Also, while it is physically and technologically possible to do a lot of things, you need to set rules of the road if there are going to be a number of organizations that are going to be taking part
Yeah.
in these activities, and that's why we have all of these policies.
Because we can't have the
Yeah.
anarcho-libertarian paradise where, oh, I guess the rocket blew up and killed like 10,000 people. We'll just go to the next one. I don't think people are going to like that. Like, I think we have to set some rules and boundaries and make sure people stay in their lane. Otherwise, it's a very dangerous business, and can get even more dangerous if we start peeling back the regulations and the rules that we've already put in place.
Sure thing. So, speaking of rockets blowing up, or in this case, not blowing up, thank goodness, there were two scrubs of this mission. But on November 18th, the first in a series of four next generation weather satellites, known as the Joint Polar Satellite System 1, or JPSS 1, was placed into orbit. Finally, yay! Throw a round of applause into here. This one, so JPSS 1. For those of you who aren't familiar, it was built by Ball Aerospace with a number of other collaborators. And it once again is the first of four in an $11.3 billion, that's billion with a B, NOAA program to provide continuous low Earth orbit weather monitoring throughout all the way through 2038. Right, so for the next 21 years, this thing is going to exist and be providing us some of the best Earth observation data that we've ever had. The polar orbiters will work with the more familiar geostationary operational environmental satellites, GOES. We've talked about those on the podcast before. It's going to work with those weather stations that provide hemispheric views from their lofty perches of over 22,300 miles above the equator. But it's the polar orbiters that provide sort of the lion's share of things. 85% of the data needed by the computer models to generate the forecast familiar from nightly television newscasts. So, like I said, two launch attempts for the JPSS-1 had to be scrubbed early in the week. One of them due to a boat that strayed into the restricted zone for the launch. That might be the third or fourth time I've heard that this year. Like, it's ridiculous.
Stray vessel runs risk of canceling entire space mission.
Yeah, like a $1.6 billion satellite. It's insane how we can't regulate that. I'm wondering what punishments, if any, there were for that, because you're disrupting a major government operation when you're doing that. So I don't know. But
well, with the whole aircraft one, what was that, last week or 2 weeks ago? That's FAA's jurisdiction. Who has jurisdiction over the water? Is that the Maritime Association?
Well, it's not like who the hell is that?
Yeah, I'm gonna look that up.
Wow, I feel like I should know that. Anyway, yes, look that up. But so the boat was one issue. There was another technical glitch with weather concerns. But on Saturday, November 18th, the countdown went smoothly. They had a liftoff at 1:47 a.m. A little bit about that launch. They had 6 solid fuel strap-on boosters. Those all burned out and fell away as expected about a minute and a half after the launch, followed by 3 that were ignited in flight. This was the Delta II rocket. The Delta II's first stage RS-27A engine shut down and fell away a little more than 2 minutes 2 minutes later, and the flight continued on the power of the rocket's AJ-10 second stage engine. The second stage reached the intended preliminary orbit about 10 minutes after launch. A second engine firing 40 minutes later completed the trip to about 512 miles in a 101-minute orbit around the Earth's poles that will allow that will allow JPSS to monitor the entire planet as it rotates below. So it was a great launch. Once again, this is a joint project between NASA and NOAA. NOAA's sort of been at the helm, but NASA has done a significant amount of work on this project. It's designed to provide readings for atmospheric temperature and moisture, clouds, sea surface temperature, ocean color, sea ice cover, volcanic ash, and fire detection. I believe we have discussed JPSS and some of the instruments that they were building to put on board of it in previous episodes. So go back and look in our archives where we kind of did a deeper dive on that. But this is actually pretty relevant to a lot of things that have been happening lately with all of the hurricanes and things like that. JPSS-1's data should lead to improved storm forecasts as well as more accurate assessments of post-storm damage. Once it's settled into its final orbit, apparently the satellite's going to be renamed NOAA 20. And one thing that also happened with this, the satellite was actually launched with 4 additional satellites that were ejected into orbit. So JPSS-1 was just one out of the 5 that were brought into orbit. 4 of them are part of a NASA educational program and will test new technologies ranging from radiometric weather monitoring and the effects of space radiation on electronics to 3D printing in space. So JPSS-1 had a little company as it was going up. But
well, I mean, that just makes it all the cheaper.
Yeah, exactly. Yeah, we can like bring multiple experiments up there now. But yeah, everyone at NASA was insanely excited. I've been seeing signs all over Goddard for the JPSS-1 launch, and I look forward to all of the data that we get from it, as well as future JPSS missions, provided they're funded.
So I've been doing a little bit of digging around, trying to figure out what to answer the question of, if FAA covers the skies and the Highway Administration covers the roads, who covers the seas? And if you look up whose jurisdiction is the sea, I don't know, but that's a cool band name to begin with. But
it's partially Homeland Security, right?
Actually, no, it's Department of Transportation.
Oh, I guess that makes sense. Yeah.
It is the United States Maritime Administration, MARAD.
Interesting.
Which sounds like it should be in DOD if it's like MARAD. That sounds
that does sound like a DOD name.
And they have a budget for 2016, their enacted budget was $399 million.
Yeah. Okay.
So, yeah.
Well, there you have it. So get those people out of the way of our space launches.
Yeah, MARAD. Come on.
Do a better job, MARAD. No wonder no one knows who you are. Anyway.
Well, so JPSS-1, I guess NOAA 20 once it's fully operational.
Yeah.
I think it's really important to note that this is where you draw your distinction between NASA and NOAA. I know there's been a very big policy discussion, and especially in the last election, there was a lot of talk about consolidating the civil space program into one agency. As it stands, there's 5 departments and NASA that all have something to do with space. So you have things like FAA within the Department of Transportation. You have FCC underneath Department of Commerce, NASA, NOAA, all these other organizations.
I mean, you have NASA with, for all intents and purposes, is technically the civil space agency, right? All these other groups have significant applications that rely on space infrastructure.
Yeah. NOAA's, $5.5 billion, I think, was their budget last year. Their budget is not expressly all spent on space, but something like a $1.6 billion space mission that covers 4 or 5 satellites, including JPSS-1?
Well, wait, you mean how many JPSS are there going to be?
Yeah, 5,
There's
right?
supposed to be 4. There's supposed to be
4.
4, and
Okay.
yeah, it's going to cost
So
11.3 billion overall.
yeah, so, yeah, 11 billion over, the next decade and a half, 2 decades is, I mean, that's a lot of money for a small agency like NOAA. But the benefit that NOAA has is that, where NASA is the civil space agency, they focus most of their efforts on developing capabilities, so SLS and Orion, and working on the almost one-off programs. Like, it's not like you're going to have Cassini 1, Cassini 2, Cassini 3, Cassini 4 all going to Saturn. You have one Cassini. Or Juno, you only have one of those. I mean, for some missions, it does require having multiple spacecraft over a period of time. If you can look at the Mars exploration program, you see multiple rovers, all with the same idea behind them,
Particularly
going
when
to
it comes to
Mars.
Earth observation. I mean, that's a
Yeah,
very
but
common
that's
thing to
NOAA,
have
and
multiple.
that's where I think the distinction is
Hmm.
when you start needing multiple satellites and coordinating all of those efforts and sort of maintaining that day-to-day operation, that's where you start looking towards something like NOAA, where they're not the civil space agency, but they use space in such a way that it requires daily maintenance. Not to say that Curiosity doesn't need daily maintenance, but it's not it's one that's like one mission, and you have your people that are assigned to that. They don't really do
Hmm.
anything else. But then the people within NOAA who work on JPSS, or the folks that work on like the A train is a NASA satellites that are being run by NOAA so that they can maintain the daily operation. That's sort of how I break it up in my head, is that NASA's the big one-off missions, and NOAA is your routinized daily operations of satellites in around Earth. Is sort of, I mean, again, it's not that's not the that's not the legal breakdown between NASA and NOAA, but that is the patented Jack Corelli method of understanding NASA and NOAA.
There are blurred
Um,
lines between NASA and NOAA. I mean,
yeah,
in
and
term,
you see companies like Ball Aerospace, who are building the JPSS satellites. Though Ball Aerospace also works with NASA primarily for a lot of their missions. Lockheed Martin, Boeing, SpaceX all launch NOAA missions and are integral to the mission of NOAA, but their main contracts come from NASA. So you see crossover between the two agencies, but it's important. I guess this is the thing, is that I don't think NOAA is given a lot of credit for being what it is. I mean, for $5.5 billion, we are operating hundreds of satellites around Earth,
yeah,
all thanks to this little agency
yep.
based out of Silver Spring, Maryland.
Who are investigating this whole global warming hoax. I know, it's insane how much of our
Man, we
tax
spend
dollars are spending on it.
$5.5 billion and we get all of this fake data. It's great.
From the Chinese too. That's
Yeah, I know. It's a
yes.
steal. It's a
The
steal.
Chinese are running NOAA. You heard it here first. But anyway, yeah. So that's JPSS. I can't wait to hear about the data that comes back from that and how it can help with future predictions, especially when it comes to weather forecasting here on Earth. So moving right along to international news, India and Japan are talking about a possible joint mission to the moon. So ISRO and JAXA, the Indian Space Research Organization, and the Japanese Space Agency are talking about an actual joint mission. The mission will include landing on the surface, exploring the moon by combining forces, and returning with actual samples. So it's a sample return mission. So this is neither India nor, I believe, JAXA's first trip to the moon. I know India had I believe it's pronounced Chandrayaan moon vehicles. One that was launched, I want to say, it was back in 2015 or 2016, and the other, which is planning on being launched in the first quarter of next year, 2018. Next year is a big year for space. It really is.
Let's just hope it's not when we get to 2018, we're saying 2019 is going to be a big year.
It's going to be huge, man. 2019.
I promise. Mars is 20 years away.
Right. But so the two agencies, JAXA and ISRO, have begun preliminary discussions, and further talks are apparently underway. The mission is also meant to improve the relationship between both countries so that you can see more cooperation between both of their governments in multiple capacities, which will also influence all other facets of things like e-commerce and things like that. Just having those two countries work together. This is space bringing countries together. The discussion has begun on sort of what the data, what kind of data they want to collect and the major targets that they want to hit. Speaking out about the joint mission, JAXA Director Naoki Okumura said that last year an alliance was signed between the two countries, and they believe with this new project they'll be able to lead the space sector in the Asia Pacific region. I almost said Asia Pacific. Wow, I came this close. It's late, guys.
Can you be more specific?
But both agencies are also focusing on generating inputs for climate change as well. So they're looking at working together in a big way and building up Asian capacities in space. Talking about the cooperation, ISRO Chairman Kiran Kumar said that there will be a visible change in the relationship between India and Japan, and that they are looking forward to the future cooperation. So significant amount of discussions. It seems to be, and I don't mean this in a bad way, but there is a lot of talk that's happening right now, which is how all of this has to start, and planning that's going into it. So, overall, what they want to focus on is attempting to join forces to cut down the cost of getting access to space and making that access cheaper. I know specifically ISRO had been focusing on that throughout the years, but with better cooperation, it's easier to sort of execute that goal. So, we'll see what comes of that. I'm sure there will be more news, likely next year, as they come up with a much bigger and better plan on exploring the lunar surface. See, other countries can explore the lunar surface.
Yeah,
we don't have to do that.
And so this is, I guess, integral to the whole idea behind the Deep Space Gateway. So we talk a lot about Deep Space Gateway in this almost it's going to do a million things at once, and this is, I guess, I've started to get a little worried because that's the same way that we talked about the International Space Station. Well, when it was Space Station Freedom, when for about 15 years into development before we started building it, because we didn't know what it was going to do. But this is one of the things that I think is almost without this, Deep Space Gateway is going to be a non-starter, is you have international partners chipping in for the Deep Space Gateway itself, but then also using that as a platform for lunar missions.
Right.
So say Japan wants to send a lander to the moon, they send the parts up to Deep Space Gateway, they assemble it there, and then they send it down to the lunar surface. And I think that seeing this cooperation between between countries and other countries that aren't the U.S. is going to be really important to the success of Deep Space Gateway and the entire international regime for space cooperation.
I kind of see Deep Space Gateway, honestly, at this point, as all of these other countries sort of build up their capabilities, their capacities for going into space and having somewhat of a space infrastructure, as something that we launch at first that's relatively small and then just is built upon over time. Yeah. I can definitely see
we
that
need to be prepared. We need to be prepared for Deep Space Gateway to basically become the next ISS that we're going to be spending a couple decades there, or at least a decade and a half there, building it out and creating what we want it to be. Hopefully that then doesn't impact the deep space transport, which is going to be our vehicle to getting to Mars and beyond.
Well, this is what I'm saying. I think we'll be running the Deep Space Gateway, just because we will have will have built it at first, but I don't. I could see other country more of the focus on it being other countries wanting to use it while
Hmm.
we're building up our and focusing on our capacity to build the deep space transport and other capabilities for launching from there or using it as sort of a relay point.
Hmm.
I think that'll be our main focus, 10-ish years, 10, 15 years from now. Whereas other countries will be wanting to attach to it and starting to do their own research out in space and wanting to attach new instruments, attach even new platforms to it, and assembling this as a sort of a much bigger platform than we originally envisioned out in cislunar space.
Hmm.
And for that, I say more power to them. It would be great to actually have a solid space platform in cislunar space as opposed to sort of um a tiny relay point. I just don't want the US focusing on that. Right.
Yeah, I don't want our $20 billion a year space agency to be focusing on something
Yeah.
that's not even as big as a townhouse in
Right.
downtown DC, um, as the next big mission. Yeah, I don't want it to be ISS 2.0 in that we sink so much investment into it and don't really see
The
the
US seeing so much investment. Yeah,
yeah
like
the
that.
US
Yeah.
and we not really see as big of a return on our investment as we have seen with the ISS.
Hmm.
I mean, the ISS was supposed to be the rally point for missions to the moon, missions to Mars, and it just was never utilized that way. But I think if you have this going into the Deep Space Gateway with these, the lessons learned from ISS, we can say, all right, well, we're going to require 50% or more of the funding for DSG and also of building DSG is going to come from international partners, and that all of the missions down to the moon are going to be, international or commercial partners. And then that allows the US to focus our abilities on getting to Mars and beyond.
Okay. And now for latest in tech, a little bit more of local news. JPSS is definitely local news.
Yeah.
But on November 3rd, Parker Solar Probe passed vibration testing at the Johns Hopkins Applied Physics Laboratory, or APL as we call it around here, in Laurel, Maryland, where it was designed and built. And recently, on November 14th, the spacecraft successfully completed acoustic testing at NASA Goddard Space Flight Center in Greenbelt, Maryland, and is now being prepared for further environmental tests. Now, I think the first time I actually visited the acoustics facility was with you, Jack, with the Planetary Society.
Yep. It was our tour of Goddard when we saw James Webb just after they put the last
Yep.
of the 18 mirrors on.
Yep. Now, if you haven't been to Goddard's acoustic test chamber, it's a 42-foot tall chamber that uses 6-foot tall speakers, which can create sound levels of up to 150 decibels to simulate the extreme noise levels of a rocket launch. While vibration testing focuses on how much the spacecraft will shake during the launch, acoustic testing subjects the probe to intense sound forces like those generated by the Delta IV Heavy. Each type of force affects the spacecraft differently, so both tests are necessary. That's why they're both executed. James Webb had to undergo the similar testing as well. But yeah, when NASA's Parker Solar Probe lifts off on top of a Delta IV Heavy launch vehicle in the summer of 2018, fingers crossed, because delays never happen in NASA.
Oh, never, especially when Goddard's involved.
Yeah, exactly. Hey, let's not hate on Goddard, right?
Yeah, no,
Space is
Goddard is
hard,
great.
right?
Goddard is great.
Space is hard, and it takes a lot of cooperation. But the Parker Solar Probe seems to be on its way, though. So is James Webb, but yeah, that's neither here or there. It will, but yeah, when it gets ready to take off, it will undergo both intense vibration as well as acoustic effects of the sound of both the engines and the rocket going through the atmosphere. Now, this was actually initially named the Solar Probe Plus spacecraft, and they renamed it back in May after the astrophysicist Eugene Parker, who did groundbreaking research in solar wind and solar magnetic fields. It's also an interesting orbital dynamics demonstration. This launch. So the idea behind this solar probe, it's the first probe that we've ever sent to the sun, to a star in general, right? Because the sun's the first star we will have ever been to. But when it takes off in 2018, it will use multiple gravity assists at Venus to remove the Earth's angular momentum from the orbit in order to drop down to a distance of about 8.5 solar radii, which is about 5.9 gigameters from the sun. Parker Solar Probe's mission will be the closest approach to the sun by any space mission by far. And it's going to perform a series of scientific investigations in clearly a very hazardous region of intense heat and solar radiation. The spacecraft is going to fly close enough to the sun to watch the solar wind speed up from subsonic to supersonic, hence why they renamed it after Eugene. And it's going to fly through the birthplace of the highest energy solar particles. To perform this sort of unprecedented investigation, the spacecraft and instruments will be protected from the sun's heat by a 4.5-inch thick carbon composite shield, which will need to withstand temperatures outside the spacecraft that reach, nearly 2,500 degrees Fahrenheit. So not too hot. The primary science goals for that mission, because I don't think we've talked about Parker Solar Probe. So the primary science goals, by the way, are to trace how energy and heat move through the solar corona and to explore what accelerates the solar wind, as well as solar energetic particles. Scientists have sought these answers for more than 60 years of studying the sun using the equipment that we have at NASA, but the investigation requires sending a probe right through the 2,500 degrees Fahrenheit heat of the corona. Today, this is finally possible with all of the thermal engineering advances that can protect the mission on such a dangerous journey. There's going to be 4 instrument suites on the actual probe. Like I said, one to study the magnetic fields, one to study plasma particles, one to study energetic particles, and one to study one to actually image the solar wind to make sure that our models are sort of align with them. And that's kind of the interesting thing about this mission is we've investigated the sun so much. It's the star we've had sort of the longest period of time investigating for very obvious reasons. And we have a number of models, a number of assumptions, and we feel like we've studied it and have explored it so much, but we've never actually been there. And this is going to be the closest that we've ever come to actually being there. 8.5 solar radii away. That's pretty damn close. So
what is that in AU?
8.5 solar radii? That's actually a damn fine question. I mean,
see, that's what I'm here for, is to ask the damn fine questions.
So let's see, 8.5 solar radii. It's, what did they say? 5.9 billion meters away, and AU. Let's see, 1 AU is how many meters away? It's blah blah blah. It's like, I want to say it's about 150 million meters, right? 1 AU. So that is upwards of, love that you have me doing math here. It's late, sorry, ladies and gentlemen.
It's 0.0568 AU. So it's 5% the distance from the sun to the Earth.
From the sun that the Earth is, yeah.
The average distance, because as we know, orbits are elliptical, but like the average distance from the Earth, or from the sun to the Earth, is 1 AU. The average distance that Parker Solar Probe will be from the sun is going to be 5% of that. So that's really, 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 really
It's insanely close. It's insanely close. Yeah.
Like, I don't even think you could measure the light from the sun in even light seconds at that point.
Right.
Like, right. You'd be about as close to the sun as we are from the moon. That's pretty
It's
close.
insane.
Yeah.
It's crazy. So yeah, I mean, I'm anxious to see just how closely everything that we've studied from the sun like actually aligns with what we witness bringing our best instruments, and I'm really hoping the spacecraft actually survives. The big if there. I mean, technologically speaking, the some of the things that they're talking about here, and we'll post this article online in terms of in terms of the shielding. Obviously, not something that a human could withstand, but as far as something that a probe could withstand, it seems like the carbon composite shield that they're building up will actually should actually hold throughout the mission. But yeah, I'm really interested in seeing what we actually get, particularly from the solar wind models, and I don't know if there's going to be much to learn from, well, how much we can learn from the plasma and energetic particles, because we've studied some of those before, but this will give us more samples, and of course, getting a close up of the magnetic field will certainly prove to be interesting. So we'll see. We'll be about, what is it? So this is planning on being launched in summer 2018. So it's pretty darn close.
Yeah. Also, I may have overstated how close Parker Solar Probe will be to the sun. It's not going to be as close as we are to the moon. That is really close.
Well, you know what? I was saying that it was. I was saying that it was 5.9 gigameters because the site said that.
Yeah.
But it's actually 8.5 solar radii is about 6 million meters. So
600,000 kilometers.
Yeah.
Yeah. Okay.
That's pretty damn close.
Yeah. Yeah. All right. Anyway, so on to coming soon to space.
Yes.
We're going to be focusing our last bit of our conversation here. Yeah, I know the episode's going to be about an hour long, but so the first thing I wanted to highlight was on planetary.org. Our friends over at the Planetary Society have put together Emily Lakdawalla, who is an amazing space communicator and science communicator who's on staff. And she's the senior editor of the Planetary Report. So if you're a Planetary Society member, $4 a month, you get these every 3 months, and she's the senior editor behind it. Anyway, so Emily has put together a list of recommended space books for kids of all ages for the year 2017. So if you have kids, or you know people that have kids, or you know that kids exist and want to give them a present to inspire their interest in space, this is a great resource to go to. It's broken into age groups, so for preschoolers, for young children in the elementary school range, all the way to middle school students, helping to foster interest in space. And so some of them are Exploring the Constellation by Sarah Latta, for specifically for early grade school, or Q&A about the Earth. Aliens Get the Sniffles Too is the one that really caught my eye, talking about planetary protection. There's a lot of cool things discussed in these books, and would make great gifts to the families that have children in your life. So
cool.
Holiday season's upon us. Get them the gift of knowledge.
Get those sales, guys. And speaking of sales, space.com also has a list of the best Black Friday 2017 deals for space fans as part 2 of our Coming Soon to Space. Yes, beyond books. This and beyond just gifts for kids as well. These are gifts for hobbyists, space beginners, sky watchers, as well as kids. There's a number of telescopes and binoculars that are pretty cool on here, some of which I might buy. I'm not going to purchase this. I might purchase this telescope, even though I'm planning on building a telescope this winter. Hold me to that.
I will.
I was supposed to do this with a good friend of ours last winter, but that just didn't end up happening. It's happening this winter. Yeah, but there's a pretty dope refractor telescope on here that I might purchase and just have 2 telescopes. But yeah, and then there's some great toys and Lego. Don't forget about the NASA women, the Women of NASA Legos that are coming out fairly soon. And there's also some Lego Star Wars, a lot of Star Wars themed things, for obvious
It's
reasons.
almost like there's a movie coming out.
Is something coming out? I didn't know. I know I won't be here for it though. But yeah, so check it out. Go to space.com. We'll have a link in the show notes for it. So
great. So yeah, that just clocks us in under an hour.
We're just under an hour. Good job.
Yeah. So I hope everyone who is listening has a wonderful Thanksgiving. If you're going home or going anywhere for this holiday, please be safe. I know I will be traveling tomorrow. So we're actually changing our recording date. We are recording on Sunday night. I have a flight in about 18 hours that I haven't packed for. So I will be, when you're hearing this, I will be in the great state of Michigan, enjoying the cold weather and probably some warm apple cider. Newton, you going anywhere cool?
I am going
hot?
to the great city of Washington, D.C. and chilling here. Well, my family's coming down, so.
Cool. Yeah. So yeah, and we will talk to you all after this Thanksgiving break, and hope everyone has a great Thanksgiving.
Yeah.
So
right,
as always, I'm Jack.
And I'm Newton.
Ad Astra.